Hello, good afternoon. Welcome to this GSE session. This afternoon, we're going to talk about OpenTelemetry and how it improves end-to-end observability on the mainframe. Very lucky to have Rudiger Schulze, who's the tech lead for OpenTelemetry on Z, and Chris Walker, who's the product manager for IBM Z AIOps, including the products that exploit OpenTelemetry. This session is going to be recorded. Every attendee is muted. If you have questions and you're watching this session live, please put them in the Q&A and I'll either get them answered in stream at a convenient point or at the end I'll unmute you. If you're watching the recording, by all means, please contact these guys or myself, Matt Roseblade at IBM, and we'll be happy to help you. Over to you, speakers.
Okay, good morning, good afternoon, wherever you are. My name's Chris Walker. I'm product manager, as Matt said, for Z AIOps, and Rudiger is joining me here. So we're going to jump into the topic of OpenTelemetry today. We're going to run through what OpenTelemetry is, the benefits around it, and then the main part of the presentation is going to be around some of the key use cases of exploiting OpenTelemetry. And then at the end, we'll run through the details and you'll have the opportunity to answer questions. So I will start with the overall topic of OpenTelemetry. I know it's been a topic that a lot of people have learned about in the last 12, 18 months, but for those of you who are not completely familiar with it, let's give you a big overview of why it's important. And one of the main reasons, because we're looking at this from a mainframe point of view, is that we know that the mainframe is part of a bigger ecosystem. We have what we might call hybrid applications or workloads that traverse many different technology stacks. They may be, in some cases, a mobile-fronted application that calls through some cloud or VM services, but ultimately drives a transaction on ZOS in Kix and updating something in DB2. And there are many stakeholders involved in managing that hybrid application or customer journey that is occurring there. There would be an application owner who is ultimately responsible for the availability and reliability and performance of that overall application. There will be SREs and enterprise IT operators who are looking at some of the front-end workloads. There are application developers who are making changes, and very much these days you can see parts of the application being updated perhaps multiple times during a day through a CI/CD pipeline. And we have our traditional mainframe subject matter experts who will have deep knowledge in things like Kix and IMS and DB2 and the platform itself. The thing is that it is a challenge because each of these people are important to that overall success of that application, but they all have their own particular perspective of what is going on there, and they're all using different tools that may be not connected or have taking samples at different times or look at it in a slightly different way. And with this disjointed or siloed approach means that it is difficult to detect, to isolate, and ultimately resolve an application problem if it is occurring. And this is where observability really comes in. So observability is not just another term for monitoring. I think of more of observability as looking more of an outside-in view of the application or the journey that is occurring there. So on the right, the application might be made up of things from the cloud, from Z, all being pulled together within that. What is important here is that we get the signals or details around what is occurring in the environment to be coming from all of those parts, and we correlate them and analyze them together in order to get actionable insights around what is occurring within the application. And when we have that actionable insights, we can look at that in terms of dashboards, and we can have the various stakeholders looking at it in the perspective that they require. But we also have the view of the application in terms of that application itself, and not just in its composite parts. That can then lead to improvements in terms of the detection and the isolation, but also being able to automate the response to do that, and ultimately driving down that time to resolution. Okay. So this is where OpenTelemetry comes in, because as we have all this disparate heterogeneous environments that have got lots of different technologies involved, it is very difficult to have a single solution that will solve everything. For many years, APM solutions have been very dependent on the agents and implementations of a particular vendor, which may be strong in one area, but not in another. What has been driven in the last decade, but particularly in the last 5 years, as we move to a more containerized, cloud-based environment, there was a big drive to make sure that we can do monitoring and observability within that space more effectively. And several initiatives came through, and there's been movement in the space in the last 3 years to come towards a standard known as OpenTelemetry. And what this provides is a vendor agnostic way of a framework of generating and processing these signals or details about what is occurring there. And we often talk about metrics, traces, and logs within there. A trace being the flow of an application or a flow of a transaction through the system, metrics around how the service is running, so something like CPU utilization or the amount of storage that's being taken part there, and logs. We've had logs for a long time, but basically have a timestamped information around the details that are within there. There may also be other things such as baggages, so there might be additional contextual information around what is occurring in there. Now, these create within OpenTelemetry a standard called spans, and these will be correlated together in an observability backend. Observability is not being a product in itself, but the framework around it, and a collection of the standards and also SDKs in order to generate that information. This is really important because it allows us and allows vendors and also consumers to provide a more holistic solution across there. And we know that this is important because as it's been managed by CNCF, we can see how popular it has been over the last few years. CNCF manages hundreds of projects. Some of them are quite small. The largest one over the last few years has been Kubernetes in order to do container orchestration. The second most popular project in terms of active development and pull requests is OpenTelemetry. We also know from analyst reports that there is a lot of enthusiasm for this part for OpenTelemetry at this point. Monitoring and observability is growing up in the hype curve, and also OpenTelemetry is close to the peak at this point of the Gartner hype curve. And speaking personally as well, I know from talking to many different clients and customers that I work with in the mainframe space, the topic of OpenTelemetry has become very important over the last 12 to 24 months. You can also go to the OpenTelemetry website, opentelemetry.io, and go and look at the ecosystem of all of the different vendors, both on the mainframe and outside, that are looking to embrace it, and either as a backend to process it, or also to support it on their platforms as well. So with that, I'm going to hand it to Rudiger, who's going to go into more details of OpenTelemetry and the technical background around it.
Yeah, thanks, Chris. Thanks for the introduction into observability and OpenTelemetry here. So now let's look at the benefits of OpenTelemetry that it has from a customer perspective. And there are a couple of things that you need to take into consideration. So this is talking about the impact of OpenTelemetry that it has, but also then, of course, we want to look at the value of OpenTelemetry. And when we, go back and look at previous application performance management tools and generally monitoring suites that have been vendors being creating and providing, then usually all domains of monitoring of the stack, they have been in the responsibility of the vendors itself. So, and this goes across the creation of dashboards based on the telemetry data that is coming in, but also creating the backend and storing the telemetry data, and then most important, the instrumentation. There may have been some open source being involved in this process, but there was not until OpenTelemetry and it's earlier projects in the open source space, really a large footprint of open source that has been used in this space. And this is changing with OpenTelemetry. OpenTelemetry is really creating an open standard for the instrumentation of different sources, so that then these different types of signals can be supported with telemetry data. But also it takes care, as we have seen with the collector, with the OpenTelemetry collector, about the export and the transport. So the combination of the collector together with the OpenTelemetry protocol is actually providing then the standardization in terms of export and transport. And what that implies for the observability vendors is essentially they need now to put more focus on analysis and correlations within their products, because this really becomes the differentiating factor. Instrumentation is no longer a differentiating factor in this space as it becomes an open standard. So now the purpose and the task here to those vendors is really to look at creating additional value for their clients based on advanced analytics features, so that there can be a faster response time to incidents being achieved. From a client perspective, the value of OpenTelemetry is actually in multiple areas. So first of all, OpenTelemetry is really defined by the specification in a way that these different signal types, so traces, metrics, and logs, can correlate with each other, can be correlated with each other. So specifically, this for instance, implies that if you have a specific log, this log is defined in a structured way by OpenTelemetry, and it can have a reference to a specific trace. And that would allow you to easily then navigate from logs to traces and vice versa. And the same principle actually applies to all those signal types. Based on the telemetry data as it's being provided and as it is being annotated, and annotating is here another aspect, so providing additional metadata to this telemetry data is essential here, as it gives kind of like a self-describing way of how the telemetry data is being exposed. Then observability products can create topologies, and importantly about these topologies is you can then, for instance, have application components being put in context with the respective infrastructure, and that in the end creates better visibility into the distributed application together with the infrastructure, but also then allows a better problem determination and isolation of where a potential issue is occurring. When we look at OpenTelemetry and now apply OpenTelemetry to the mainframe, I think what we assume there is that OpenTelemetry will come into play in multiple ways. So we have seen earlier that with OpenTelemetry we get different types of instrumentation, and that will allow us to get telemetry data. And when we look at the mainframe, what we assume is we will have native instrumentation. So some of these components that we have today at the mainframe, they will expose OpenTelemetry data and telemetry data through the OpenTelemetry protocol. Versus as we have an existing ecosystem of different types of systems management products and monitoring, observability, but also AIOps products, there will be as well then an integration of OpenTelemetry, so that these products will either take advantage of data streams that come in with OpenTelemetry protocol, but also they will be enabled to export OpenTelemetry protocol to then other targets. And as we are embracing OpenTelemetry for the mainframe, we have multiple initiatives ongoing here, and we will see as we progress in the presentation, we will see more about that. But I just want to introduce here the special interest group for OpenTelemetry on the mainframe, which is a work group of the OpenTelemetry open source community with a focus on enabling OpenTelemetry for the mainframe, Specifically, we are looking there at semantic conventions. We will hear about that more as we progress in the presentation, but also we are looking at porting the OpenTelemetry components to the mainframe. So you have seen the OpenTelemetry collector, but we also talked about code instrumentation, SDKs. The aim here is to make them available for the mainframe. The other initiative that we have ongoing is the sponsor user program here at IBM, which has the objective to get requirements from customers, specifically to observability, but also to OpenTelemetry, as we are hearing that there is a strong focus in the customer base already on this topic, and then provide respective support for this in future. Now let's dive into use cases of OpenTelemetry, and we will be looking at 7 use cases for OpenTelemetry within the presentation here, and I would like to start with code instrumentation. Code instrumentation is really about enabling your code, your application code, to expose telemetry data. And again, telemetry data, we speak here about all these signal types. So metrics, logs, and traces, as well packages, as we mentioned. And just since this year, also OpenTelemetry has now a focus on profiles. Excuse me. So profiles essentially would allow you then to see how much capacity a particular piece of code has been consuming, or how much resources essentially has been a piece of code being consuming. And with this code instrumentation that is available, there's a set of SDKs for the languages which you see here on the screen. So all these languages which have a popular appearance in the cloud native world, they are in the meantime supported. There are still some implementations that need to achieve the stable state, but this is essentially because as OpenTelemetry as a specification has been put in place, traces was the first where the specification was ready, so the implementation started there. Logs just was as a specification stabilized in the last year, so these implementations, they are just catching up. There are 2 types of language instrumentation that are supported by OpenTelemetry. There's automatic instrumentation, and that allows you to just get telemetry data by configuring your runtime environment in a way so that you can get these telemetry data being exposed. And then there's manual instrumentation, which would imply that you have to change your code. You see here on the lower left part, this little icon, contribute to the SIG hotel on mainframe. This is about the special interest group that I mentioned earlier. We really would like to bring all these different types of SDKs to the mainframe. That would imply COS, Unix System Services, but as well then Linux on IBM C. As we are progressing, let's take a closer look at what auto instrumentation really looks like. And this is an example based on Java. And as I said, it's really about just configuring your runtime environment in a way that the OpenTelemetry agent can be used to expose those specific telemetry data. Here in this case, we are looking at a specific trace of an application, of a very simple application, so that you can see how the requests are being processed. And when we talk about automatic instrumentation, essentially what is captured is the incoming requests and the outbound requests. So here in this case, even if it's very small on the screen, that would be HTTP requests coming in, and then an outbound request would be considered here a call to a database backend, and for this database backend, then the automatic instrumentation would be capturing the respective client span to the database with, for instance, the SQL statement, and that is all happening in an automated way. So there is no code change required by the developers to get this done. It's rather configuration. Opposite to this, we have manual instrumentation, and that's a very simple scenario here, but just to get the idea, it's taken from the OpenTelemetry SDK for C++, where you can see here the invocation of the tracer, get tracer functionality, and then with the get tracer, you start the span, you give the span a name, for instance, F1 and F2. And then with this, you enable your code to export trace spans. And if you have the proper configuration in place, then the data is directly sent to an observability backend. And as you can see here on the right, then the observability backend is building up the respective trace spans, and you get visibility into, for instance, aspects like how long did a specific function or operation take, but also what kind of calls have been made in this scope. And then you get additional attributes, and these attributes, and if you do manual instrumentation, you would have just to set yourself. In case of automated instrumentation, those would be provided depending on what we are dealing with. I spoke about HTTP earlier. There's a specification by OpenTelemetry what kind of attributes an HTTP request would have to expose, similar for databases. Let's take at the second use case, which is OpenTelemetry being used for telemetry distribution. In telemetry distribution, this really goes into the area of the OpenTelemetry collector. The OpenTelemetry collector is really a strong piece of software to define telemetry data streams and pipelines of the telemetry data streams. And the way how you do this, you apply a configuration to your collector that defines what kind of receivers, kind of processors and exporters you want to use for your pipeline. And the receiver essentially takes telemetry data from a source, and there are different types of receivers. OpenTelemetry protocol, of course, is supported as a receiver, but also any type of proprietary format is possible there. There is a registry which allows you to query for existing assets that can be used together with the collector. So, and if you, for instance, would download the collector, excuse me, if you would download the collector from the OpenTelemetry website, there are also pre-built packages of the collector that bring then those type of assets already pre-packaged. When we look at these, so these receivers, they would be capable of receiving those different types of signals. And then once you have those signals being received, there's the option to run processors. And processors, they enable you to transform the data, but also to clean the data, to add attributes, essentially to modify your telemetry data in various ways, depending on the processor type that you use, so that you can then export it towards a backend. And export, again, is very flexible here, either through the OpenTelemetry protocol or then, again, through specific exporters to for proprietary or specific third-party formats. What is of interest to mention here, almost all larger observability product vendors, but also in the open source space, these products, they are now adopting to the OpenTelemetry protocol. And what we see is that, these vendor-specific exporters over time, they will be deprecated. So this essentially makes also the life easier in terms of configuring. We have available the OpenTelemetry collector for Linux on S390X as a platform. So you can run it on Linux on IBM C. You can go to the OpenTelemetry website and download it. Nevertheless, we also would like to see, a continued contribution here towards the open source community with the SIG that we have been mentioning. There are efforts required to port the collector as well to Unix system services on COS. We know that this works. It's not as straightforward as on Linux, but now to contribute this to the community and get it into the standard release cycle, there is additional work needed. And of course, we are also thinking about extending the collector with specifics to the mainframe. Now, let's take a look how the collector can be utilized to be deployed in a mainframe environment. And as we have these different operating systems available, we want to cover all of them. And there is a setup of the collector, and this is not mainframe specific. It's a functionality of the collector as such that you can deploy it either as an agent or you can deploy it as a collector gateway. The agent is intended to be deployed locally to the source of your telemetry data. Also, the agent that would be in scenario if you, for instance, would be deploying the host metric receiver of the collector, then this specific receiver would gather all metrics of the operating system on Linux, on IBM C, for instance. So the agent can be deployed to get telemetry data locally and then also have proper addition of metadata, for instance, about what kind of host is this agent running on, what kind of architectural platform, so that you get those specifics about the source of the telemetry data correctly uttered to your telemetry data. Then the gateway is rather than in this scenario being used for controlling the telemetry data streams. And as we described, there are flexible ways of doing this. So you can have multiple of data streams. You can split data streams. You can also transform them, as we said. So that's really an opportunity there to have a centralized place to have control over the telemetry data streams that come from the mainframe. And then just to mention it, there's two more developments in the space of the OpenTelemetry collector that are of interest here. You see here these agents, they are managed with the OPAMP protocol. And that's a protocol that allows to manage agents that perform a data collection. So you could provide specific configurations and then control this as well from a centralized location. And then on the lower left part here, you see that the OCB, the OpenTelemetry Collector Builder, is being used to build specific or custom collector distributions. This is also something which is of interest. As you have seen here, the different receivers and exporters that are available for the collector. There may be use cases, there are very likely use cases where you would have a custom build of the collector which is specific to the mainframe environment. And this is something that can be done with the OpenTelemetry Collector Builder. Now, let's look at the configuration of the OpenTelemetry Collector. And there is another tool available by the open source community, which is pretty handy to do this, which is the OTelBin tool. You have the link down here on the right side. What does it show you? Essentially, it gives you a visualization of the configuration that you are creating, but it's also performing a validation against the current version of the collector, or a version that you are selecting, so that you can be sure that your configuration is also consistent with the current implementation that you are using. The example here shows 3 pipelines, one for traces, one for metrics, and one for logs. And it's very simplified here on the screen. So for instance, for traces, we would be just having an OpenTelemetry protocol receiver, then a badging of the spans. And that's a way to configure that, telemetry data is just being sent out in certain batches. And then you have an exporter with the OpenTelemetry protocol. That's probably one of the most simplest pipelines that you can think of. The one for metrics is a little bit more detailed here. So again, we are receiving the data via the OpenTelemetry protocol. Then we do an adjustment of certain attributes. We have also resource detection enabled. Resource detection adds additional attributes so that you have then, for instance, metadata being attached to your metrics from where these metrics have been gathered. And then a transformation step is being applied. And then the data is sent to 2 targets here in this case. Once it's sent via OpenTelemetry, and that could be any particular backend supporting OpenTelemetry. protocol. And then the second one, as you can see, is Prometheus. If we look at what kind of processors are there available for the collector, there's really a large set and again, powerful capabilities of transforming telemetry data. That's probably a session on its own, but just to give a couple of references here. So you have the OpenTelemetry transformation language, so a language on its own for transforming telemetry data in a central place, in fact, with the collector. Then you have sampling processors, so that allows you to, if you do distributed tracing with the collector, to reduce the number of traces which are being exported by the collector. There are certain assumptions behind that and also certain strategies. So this is really something that you need to then adjust to the specific requirements of your application. But in the end, it's a powerful way to just focus on traces which are relevant for instance, problem determination in your space, but also would address this aspect of getting not too much data from, for instance, an environment where you have a lot of transactions or requests occurring, like we have that on the mainframe. So sampling is definitely an aspect of interest here for the mainframe as well. And then we have attributes processors and batch processors. So they essentially then, like we spoke, allow you to have attributes ingested or being modified, or batches of telemetry data being created so that it is sent to the target. Now let's look at the third use case, which is observing containerized applications. And this is really about building on the OpenTelemetry collector, enabling cloud-native environments with Kubernetes or Red Hat OpenShift to support OpenTelemetry instrumentation. And there are different ways of how the operator can be deployed here. There are two scenarios given here on the slide. Just if you deploy the operator in a sidecar deployment, then you can take benefit of automated code instrumentation, as we have been previously discussing. And that would be, for instance, be applicable for Java, for applications that are, for instance, built on Java, but also there are other languages being supported. And then if we look at the deployment in the deployment mode of the operator, then this is more to just having a deployment of the collector as a way to define again and control telemetry data pipelines, like we just described it earlier. And with this, you get actually a very good support to get insight in your cloud native applications in your Kubernetes environment. From a mainframe perspective, we know that the operator as such works on OpenShift, on Linux, on IBM C. We also have been testing the automated code instrumentation that is available with the operator, but there is no support yet for all languages that are supporting automated instrumentation in the distributed world on the mainframe. So this is again a call out to also participate in this SIG, because as we need to make progress with bringing these different SDKs to the platform, we also then actually would enable the support for the operator on the platform to become more complete, specifically about the automated code instrumentation as part of the operator. Now, let's look at the topic of distributed tracing as our fourth use case. And we want to start here just with a very simple example to take a look what distributed tracing really means. And distributed tracing is if you have an application that spans across, as we described earlier, a public cloud environment, a private cloud environment, and the mainframe, what you want to see is how this application works across these different services and environments and what the dependencies are. And then distributed tracing will give you specifically a view of how your request is traveling through the system. And by this little example here, and this is a little reminiscence to 60 years of mainframe, as you can see here, a small program which is running on IBM Cloud on a Linux on IBM C instance, but also making use of the translator service on IBM Cloud. So a small distributed application. What you can see here is, first of all, what distributed tracing then gives you is a topology view, as we discussed previously, but also then you get, based on the trace bands which are generated, insight into how these requests are traveling through the different services and also what time is being consumed by those. And that's, of course, functionality where we have an interest to look at this from a mainframe perspective. So as we are getting into the area of distributed tracing, let's briefly discuss about the concepts of it. And there are two aspects to it that we need really to pay attention to, which is context propagation. And context propagation essentially implies that you have, as your request is traveling through the different services of your application, that you have context being applied and attached to the request as it is traveling across those services. And context would be that you have an identification what this request is. So that would be related to the type of request, a trace ID. And the trace ID is stable across the lifetime of the request. And then each of these services would have to be an association as part of this trace that is being built up, so that a span is representing each of the service invocation as part of the request, so that there is also then these spans get a span ID being attached. And as you are processing the request by the different services, what is altered is essentially the span ID, while the trace ID remains stable. And context propagation also implies that you can have additional key value pairs being associated with your request as it is being traveling through your services. If we sum this up, context propagation essentially means that you have a way to provide specific data that is not necessarily required for the functional execution of your application, but it provides additional metadata, which then in the end allows us to perform, to get visibility in first place, but then also to perform an analysis of the application's behavior. And the second aspect that we need to look at is the export of spans. And here we look at, of course, the export of spans in the OpenTelemetry protocol format. There is as well a specification made, of course, and the specification builds on what we just briefly described on the data about the trace ID and span ID, but then also about the additional key value pairs which can be attached. And then there can be also other data being part of a span, for instance, events, but also status information. If we look at context in more detail, then we need to get to the point which definitions are in focus for context propagation. And OpenTelemetry builds here on the specifications that W3C context, trace context, and as well W3 package define. And this is what is here on the screen in a very condensed form. But essentially, when we look at W3C trace context, we have a trace parent. Trace parent is a concatenation of the trace ID and a span ID, and also in this concatenation there's a version ID and then as well trace flags. But as you realize, trace IDs and span IDs, this is really what is essential when we come to the point of representing context, but also as well then exporting spans. Then there is trace state. Trace state is just a list of key value pairs. And then when we just take the trace context specification, that can be of a certain size up to half or 512 byte. For package, and that is then an additional way of associating key value pairs to the context. We have more, data space available to define this context. And also the key value pairs, they allow to have additional attributes being associated with those pairs so that there can be additional information being passed. Both W3C trace context and as well W3C baggage are supported by the context propagation of OpenTelemetry. And that's then building the base for distributed tracing so that we can have this context being propagated. When we look at how that works, then like I described, we would assume, or not just assume, actually we are building here on the aspect that context is associated and attached to the requests as they are traveling through the different services. Here in this screen, we have an example with an HTTP request that is coming in. Then some processing is done by the service A. There's also an outbound request from service A to service B. Again, this is done via HTTP. And the respective context, and this is here the complete set, trace parent, trace state, and baggage, are attached as part of the request and then can be also identified when you would have a dump of the HTTP request being parked by respective keywords. What is also shown here on this slide, just to complete, is this, as we have the context propagation according to W3C being depicted here, is a representation of the internal structure of the OpenTelemetry SDKs for distributed tracing. So there is the concept of a propagator that would allow to extract and inject context from a carrier, and the carrier in our case here would be HTTP as a protocol. And this context then, that's what is used by the tracer to build a respective span. So transforming the context into a span context and then into a span. And the span is then being exported to a particular backend using the OpenTelemetry protocol, either via HTTP or via gRPC. Now on COS, we have a larger set of different products that allow us to perform transactions in a very efficient way. As we are looking at this chart here, requests can come either in from the distributed applications, or it could come also be generated on the mainframe itself. But there are various different interactions between those different COS subsystems and middleware systems that we have available on the mainframe. And the objective here is really to look at those different combinations and flows that can be present in transactions as they are implemented at customers' environments. And as we are discussing about distributed tracing, then provide visibility to them. And if we take this one step further into the context of distributed tracing, what would that really imply is then, if we are looking here at an example where a request comes in from a distributed application in the x86 environment, it goes through a queuing environment, and then as well enters the mainframe via an queuing environment, and finally lands in CICS, and it does some processing on DB2 and vSAM. What that essentially implies what we want to see, and this is rather a schematic depiction here, but we want to see a trace and then a trace spans for each of these different services or COS system software components that are invoked here. And as you can see here, based on the coloration, there are different types of spans. So there are synchronous spans that need to be considered, and we would be speaking in case of synchronous processing about client and server spans, and then about producer and consumer spans in case of asynchronous processing. And this is a topic what we really want to be in a discussion with our customers. And hence, we are calling out here to the sponsor user program. So if you have an interest in distributed tracing for the mainframe and specifically for the COS system software, then please reach out to us, and we can have a discussion about your requirements, but also about possible ways of how to address this in future in the frame of the sponsor user program. With this, let's move on to our fifth use case, which is about signal correlation. And signal correlation, I started to touch on already when I spoke about the value of OpenTelemetry, but now let's take this one step further and put this into context with the semantic conventions. So as we have these different telemetry data or signal types being supported by OpenTelemetry, there is also annotation. And this annotation follows a specific conventions, which are the OpenTelemetry semantic conventions. And they are really there to provide a common naming scheme for attributes, for resources, for operations, so that then once this telemetry data is being available and supporting the semantic convention, any observability product actually can consume them and can make essentially sense of this data. And we have this work ongoing as well as part of the OpenTelemetry on mainframe. And the objective here is to come to a representation of the mainframe as part of the OpenTelemetry semantic conventions. Essentially, what we imagine, as you can see here, there's a list of topics which are covered by the conventions. And at some point in the future, we want to have a representation of the mainframe here and the mainframe concepts. And that can go from, you know, rather hardware-centric view, so like you would have it on the HMC, but also then to a COS-based view with definitions of sysplex, up to this, you know, scenarios like we just had it on the screen for distributed tracing, that you would have a description of what a kick span would carry forward as attributes. And with those semantic conventions in place, plus the already existing capabilities for correlation, then as it's depicted here on the left side on the screen, then there is a powerful method available of how you can correlate between those different signal types, but then as well get additional information about the source and semantics of those telemetry data coming from the mainframe. Now let's take a look at logging and event collection at our sixth use case. So log and event collection, as I said, was finalized as a specification just in the last year. And the objective of this definition was to not just replace what is there already, because there are powerful log capabilities available on existing systems, but also in existing programming environments today with different types of log APIs and log libraries being implemented. So hence what the community has been putting forward is different ways of how logs can be consumed. And the collector plays an essential part in this. So there would be collection gathering through, for instance, technology like FluentD. But also then there can be native log collection just from the collector, and that would be then in conjunction with applications. There's also a way described if you have instrumentation of your applications today, for instance, with a specific log library, then there is also support being added through what they call the LogsBridge API, so that you then can have translation towards the OpenTelemetry log API and consume again the data or the log data that is being generated from those applications through OpenTelemetry, and then in a defined way provide this to the observability backends. On the right side here, this is just an example, but as I said, OpenTelemetry is really focused on providing the structured representation of log, and you can see this here aside of just the actual log content. There is, you know, information like what kind of resource is being involved here, but also you would find a trace ID here. The trace ID would give you, you know, the way to correlate to a trace that this application has been issuing at the same time when the log has been generated. And there's also correlation to, events, for instance, and other information being applied. I also want to just mention that the community had a strong focus on if they have a certain sampling technology being implemented and supported by the community, that, for instance, this mechanism, as you see it here, for log and trace correlation, that is probably supported, so that if you have only certain traces being exposed, that then the respective logs would be carried forward as well. Now let's look at metric monitoring at our last use case, and that is about exposing measurements and metrics towards backends. And OpenTelemetry has here different kinds of instruments in place, and those instruments, they are there to generate measurements. And an instrument can be either synchronous or asynchronous being implemented. That's about a specific implementation point of view. But there are different types in the way of how the measurement is occurring, either as counter or up-down counter, or actually also as an histogram. The same way for asynchronous instruments, there is this counter concept being supported, or if you just want to get a specific value, that would be via a gauge. Based on the measurements, there is this concept of views, which then allow you to aggregate those measurements to then come to a final representation of metrics, which then can be again exported to any, back end for further analysis and processing. In the context of the mainframe, of course, is interesting here that we have technology available which does the instrumentation of metrics. There is many metrics as well being present on the mainframe. Nevertheless, there's also obviously the use case to export these existing data through the OpenTelemetry protocol and make those metrics available. So what that implies essentially is that there needs to be a way to intercept this process as it exists for native instrumentation in OpenTelemetry today. And in fact, that could be also a topic for the SIG OpenTelemetry on mainframe to be discussed. Essentially, for the background, to have a common approach across different vendors in the end of how this can be done, and that there's then always the same semantic being exposed as certain SMF data, for instance, is being then converted into OpenTelemetry. Let's sum it up. We spoke about a number of use cases of OpenTelemetry and how they relate to the mainframe platform. Specifically, what you see here on the slide is the current support of those different use cases by the community for COS and Linux. And as I spoke about from a telemetry distribution, a telemetry collector perspective, we have been working with the community to make the collector available on Linux and IBM C. It's currently supported as tier 3, which implies it compiles, but it's not part of the open source community test execution. This is something, as we now also have on GitHub Actions for the S390 environment available, or there are ways to request it. We probably can then work with the community to elevate that to at least tier 2. But as you can see here, there's also, with respect to the other use cases, there's still a lot of opportunity to work with the community to have OpenTelemetry better supported on the mainframe. And as I was discussing this throughout the presentation, we really look here for engagement either in the SIG OpenTelemetry on mainframe, or when it comes to distributed tracing, we would be referring here to the IBM Sponsor User Program to address this particular use case for the COS platform. I just want to briefly call out, if you have an interest on the Sponsor User Program, please contact Paolo Bocci or Chris or myself as being the speaker here. It's essentially a way of how you can articulate your requirements that you have for the platform, and then also being involved in future product decisions so that your requirements are being met. Also, I would like to refer here to the SIG for Open Telemetry on the mainframe, as I was discussing. We have 3 tracks that over time we want to address by this special interest group. So this is about semantic conventions, code instrumentation, and then collector enhancements, as I was describing. And at last, just a reference of how to engage in this SIG. So we have a weekly meeting. It's always Tuesdays at 10 a.m. Pacific time. And you're welcome to join there. But I also want to say, please make sure that you have all approvals in place that you can contribute to an open source organization like the CNCF. If you have questions about that, we can surely give you, some pointers of how to get these approvals. And at last, I want to say we would like to welcome, long-time mainframers, returnees, essentially anybody, newcomers to the platform who just want to learn the mainframe. It's an exciting topic to bring together 2 worlds, the distributed world and the observability from the distributed world with Open Telemetry, and then, of course, the concepts of the mainframe. So you're welcome to join the SIG. We look forward to meet you there. If you want to learn about Open Telemetry, there's a set of really good books out there. Just take a look at your favorite big bookstore. If I would want to recommend one, I would probably point to Cloud Native Observability with Open Telemetry, which is a good start. But actually, each of these 3 books or 4 books is a good read when you want to start with Open Telemetry. To wrap it up, we would like to ask for your session feedback, and then you find the QR code here that you can scan to fill out the survey. With this, I would close the session. Thanks for your participation. Thanks for your attendance. And back to the moderator.
Brilliant. Thank you very much, Rudiger and Chris. If you have any questions, let me know now. The room is going to stay open for a few minutes after the hour. Fantastic timing there, Rudiger. You bang on the hour. Otherwise, please send your feedback. And thank you all very much.